Hello again, you sick, twisted weather freaks. Welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week of Weather. I'm your host, meteorologist DT from WeatherIS, your captain of chaos, your colonel of confusion, your commandant of catastrophe. Let's talk about this week in weather. We got three events coming up here to talk about, or at least to watch. Some of more interest than others. There's one on January 11th and 12th, January 13th and 14th, and January 17th and 18th. So let's get right to it. First, we'll take a look at the recent, right now, what's going on here. We can see this is a surface map, and we can see our, oops, bring this forward here. We can see the low pressure area here, the main one here in the Midwest. There's the cold front, the super warm air coming up at 70s and 60s all the way up into the Pennsylvania, New York State border, so quite impressive there. But there is somewhat cooler air coming in. Now, the air behind this is not particularly cold. It's much more seasonal air, as you can see here. So there is that. Then, as we go further in time here, you can see that, look at the radar, we can see the actual conditions. And there's the front, which is now pushed through the East Coast. We've got moderate rain in New York State. I mean, in January, just to point this out, if you have rain in northern New York State, you got in Michigan in early January, you got a warm pattern. That is a warm pattern, no doubt about it. Now let's take a look at the upper air pattern and see what's going on here. Well, we have two, you can see the big upper low in Iowa and Minnesota. That's the big trough there. It's actually a closed upper low embedded within the trough. And we have another one in the eastern Pacific with another deep trough and upper low. Now this is typical La Nina weather pattern. When we talk about La Nina, what we're referring to is here's the trough coming in, and the energy. What La Nina does is it enhances the Pacific jet stream. So you start getting these really big bombs coming in, and it attacks the ridge on the west coast of North America. So if the ridge is not very strong, what happens is you get a lot of mild Pacific air when it moves across the country, and essentially in a west to east direction. So that's what we've been seeing here. So, and of course, ahead of this trough in the Midwest here, we have this big ridge on the East Coast, which has brought about the amazingly nice weather for the past several days. So, all right, as we look to the future here, let's look at our teleconnections. So here's our teleconnections chart. Now, a teleconnection refers to a particular type of climate anomaly. There are a lot of different climate anomalies or teleconnections. There's also like the Pacific Decade Oscillation, and there is the El Nino, La Nina, that's a type of oscillation. The Indian Ocean Dipole, that's another type. But in North America, when we're dealing with the subseasonal, that is to say, the next 7 days out to the next 21 or 30 days, what we call the subseasonal, there are four of them in particular. There's two on the Atlantic side, two on the Pacific side. And the red line there divides North America, as you can see it. So we have two on the Atlantic side, the Arctic Oscillation, and then we have the NAO, which sometimes is referred to as the Greenland Block, or the Greenland Low when the NAO is in the positive phase. On the Pacific side, we have two oscillations as well, the EPO and the PNA, which again run in positive or negative phases. And it is the interaction of all four of these teleconnections across North America which help determine the large-scale weather patterns. And there are several different combinations we can see here. At the top of the chart, you can see we're looking at the Atlantic side, the AO on the left and the NAO on the top. And you can see there are several combinations here. Positive and negative, neutral and neutral, negative and positive, all different types of combinations. And on the bottom, this is the Pacific chart. We have the PNA on the west coast and the EPO, which is the Alaskan Ridge. Again, there are several different types of combinations, both being positive, one being positive and negative, neutral, and so on and so forth. So there's some important information to take a look at. Let's take a see what's going on here. Well, here's the Atlantic side, and we can see the different models here. There's 6 different models, and you can see that the general trend is to keep it negative right through to about January 20th. Some of the models bring it towards a neutral by around January 20th, but for the next 2 weeks, it is essentially negative. The bottom is the NAO. Now, the NAO is neutral, and you'll see why in a little bit. Right now, it's a little bit on the negative side, but for the most part, it runs generally neutral. There is some blocking up there, but it's not over Greenland. It's more in north central Canada. So the NAO is kind of neutral right now. Now let's take a look at the Pacific side. Here's the Eastern Pacific Oscillation. This is the Alaskan Ridge. Now you want this to be negative for cold weather and snowstorm threats in the eastern half of the country. But as you can see, the EPO it's bounces back and forth, generally running slightly positive. So that's not a really good sign. It's not terrible, but it's not great. And then on the bottom, we have the P&A, which is the West Coast ridge, and that does stay generally positive right through about January 15th, and then drops down towards neutral. Now, again, so just to highlight what we're looking for here is this is what you want to have if you like cold and snowy patterns. We want to have the negative EPO, a positive P&A, and then the Arctic oscillation and the Greenland block. We both want them, the AO, the NAO, to be negative. We also want to see a 50-50 low in southeastern Canada or a displaced polar vortex in southern Canada. And then we have the ridge on the west coast. We want to see that on the west coast along the Rockies around interstate 15. So that's one thing. Now, the other thing we're going to look at before we get to the models, we want to make certain that we know where the lay of the land is here. Here's our MJO. Now, this is, again, the MJO develops in the Indian Ocean, of all places, the other side of the world. I'm not kidding you. And then actually what it is just convection, thunderstorms that develop in the Indian Ocean, and it travels along the Indian Ocean from west to east, passing across Singapore and Indonesia, north of Alaska and South Hawaii towards South America, right along the equator. And it has these different sections or phases that we refer to it. And each phase refers to specific types of temperatures and precipitation patterns. So what I want to show you here is the projections here. So this is the European and the GFS for the next 7 to 10 days. And you can see, look at the black line shows the recent trend when it started, okay? And then for the past 30 days, and you can see. And then you look at the new projections. The red and the blue lines are new projections. So see how it goes into phase 8 and phase 1? And let me call up a marker here so you can see what I'm talking about. We can see this. Oops, nope. Go back and find a good marker here. Here we go. Bring this up. I'm sorry, I'll show you what I'm talking about here. So here we go. So here is, this is like the black line is the recent trend and was a neutral circle. Then this is the forecast projections going into phase 8 and phase 1. This is the GFS. It goes into phase 8 and phase 1 in the future. Now, what's important to notice here, remember the blizzard we had back in the Midwest on the Arctic outbreak? Okay, so remember when it was back in January, it was December 22nd, 23rd, 24th, Christmas Day. Okay, right before Christmas. So the MJO on these models was over here in phase 4 and 5. And we'll get to why that's important in a minute. But phase 4 and 5 are the worst possible MJO phases for winter weather and cold on the East Coast. The worst possible. This is one of the reasons why the GFS solution, which originally had a blizzard on the East Coast, was completely bogus and the European was correct. So that we'll get to that again in a second. Now this here is the extended European GFS. This goes out to early February. And if you look at the red and the blue lines, you see they take it into phase 8, phase 1, and phase 2. Phase 8, phase 1, and phase 2. Very good model agreement. Now let's take a look at the phases. Okay, phase 1 and phase 2, there's phase 3, phase 4, and then on the right-hand side, 5, 6, and 7. So when you're in phase 8, let me show you what it looks like. Okay, you see the dark blue there? These represent negative anomalies, where storms and low pressure areas and troughs are likely to form, which will produce cold and winter weather. So if you're going to phase 8 like these models are showing, this is favorable for an East Coast storm to develop. Also phase 1 to some degree, but not as much. But look at what we said remember when I talked about just now, it was in back before Christmas when the Midwest blizzard hit and the Arctic outbreak hit, why the storm went to the Midwest and it did not go to the East Coast. Look at, again, in the pink arrow here, you can see the violet arrow, phase 4 and phase 5, phase 4 and 5. And as we go to the chart here, look where phase 4 is. Huge anomaly in Quebec, Canada, and up here in southeastern Canada. But this is, as you can see, this is not a pattern for the East Coast. Having this anomaly further up in Greenland is ideal, but having it in Quebec is not what you want to see for East Coast winter storms. So this is another reason why that big storm right before Christmas was a Midwest, a Great Lakes storm, and not an East Coast storm. The MJO was completely in the wrong phase. All right, let's move on. All right, here is what happens with the first system. Now, this is where we are for January 7th. So this is going to be for Saturday. So here we have, bring it forward. Here we have the upper low. This is the current system. Let's leave the coast now. So here's our next one. And here's the trough coming in on the Pacific, constantly ejecting these systems out of the trough across the country. Now we begin to develop a positive anomaly here in central Canada, Manitoba. So this upper low travels towards the mid-Atlantic here, moves off the coast. And it could produce some light winter weather precipitation in New York State, New England. Not a big deal, but it's possible. The temperatures are still very mild. They really have to cool down. But we are beginning to see more cold air develop with this ridge here, bringing some cold air further south. So that's a good sign, as you can see. So, okay. So as we move forward here, now let's take a look at January 11th and 12th. There we go. So let's go forward here. Now here is the GFS and the European for January 10th. The GFS, let me bring this forward so you can see it. It has three pieces of energy here. Oops. It has one, here's the northern branch, 2 and 3. See that? 1, 2, and 3. The GFS is trying to phase all three of these. The European does not do that. It has two pieces of energy here. There's no third piece up here. Now the result is important because what happens is the GFS this is from midday, the midday run, a 12Z run, it takes the energy and it phases it together into a big storm where you end up getting two areas of low pressure. It becomes a big New England winter storm. There's your ridge, okay, east of the Rockies. Here's the trough in the Pacific bringing more systems in. But as you can see, when you look at the ensembles, that doesn't support that at all. Now this is the GFS, this is the European ensemble here. See how the European has both pieces of energy lined up like this, okay? And here's the GFS showing the same sort of thing. See how they match? Notice this is the GFS. Let me blow this up so you can see it a little bit. There's the GFS. And here's the operational GFS. That is not the same. See how different it is? Again, let me blow it up here so you can bring this phone and you can bring it in front here. Here's the operational GFS from midday on this Wednesday. Three pieces of energy, but the GFS ensemble doesn't look like that at all. The GFS ensemble looks like the European. This tells me the European solution is correct for the first system for January 11th to 12th, okay? What does that look like? Off the coast. Can't quite make it. Goes off the coast. See that? Boom. Can't quite make it. There you go. Okay. Now the high comes down here. You can see the big Arctic high coming down. Look north of the Great Lakes. You can see what that does here. And what it does is it brings down the big Arctic high. It's north of Manitoba, Western Ontario. Now there's the cold air coming southward, but after the January 11th to 12th storm. So in fact, you can actually make a bit of a cold front moving through New England into the Ohio Valley here. I should have drawn it in. Now this next system here, let me call up my marker here. This next system here, that is the one here for January 13th and 14th. So there's a little bit of a cold front here. There's the big Arctic high. You see it right here, 1044 millibars. That's a really cold air. Cold air coming southward, driving the cold front. So here comes winter. Great. This is January 11th to 12th. This is the next system. This is the one for January 13th and 14th you have to watch. This is the one right here. Okay. Let's take a look-see. Now, this was the GFS solution from earlier today. You see how big storm bringing heavy snow to New York and going to snow in New England, nice, tremendous amount of wind and blizzard. Okay, this is bullshit. This is crap. Okay, this is the 18Z European, a GFS rather. Looks just like the European. There's the European 18Z. European 18Z. What does that tell you? The European's correct. This is a dramatic shift from this. Huge, huge. European's correct. Again, when it comes to East Coast winter storms, the European's far more likely to be correct. All right, let's go January 13th and 14th. Here we go. Now this is January 12th. Now notice a couple of features here. First, this is the next system. This is the one for January 11th and 12th. It's out to sea. See that? There's the cold front bringing the Arctic air in. We now have a block which has developed here in Hudson's Bay, Canada. Very significant. Now, it's not over Greenland, but it is north central Canada. And here is the next system. See how it's being forced south? See this block here? This upper low, this trough, and this block is forcing this system south. It cannot go to the Great Lakes. It's staying south like this. And that's what happens. Here's the European ensemble showing the same sort of thing. The operational ensemble. Operational, ensemble. You see how they match? You see how they're supposed to match? You want to see that with weather models. You want to see the operational ensembles match. That gives you confidence as a forecaster that they're on the same page. So there's the southern system in Oklahoma and Kansas headed for Arkansas, headed for the East Coast on January 12th. And this is what it looks like. Here's the European developing it. This is now January 13th of the evening, Friday evening. You got snow in North Carolina and Virginia, West Virginia. The Arctic high, look where it is, just north of Lake Superior. Ideal, strong north winds. And the January 11th storm, bring my marker here again. January 11th storm is now in southeast Canada here. See what this is, the January 11th storm. Look at the cold wind interaction between the high and the cold here. You're getting that strong north wind sending the Arctic air southward. And then it moves off the coast, okay, like this. Now, how far north does it come? I don't know. Okay, much is going to depend on what happens with the storm in January, the one in Nova Scotia, if it gets out of the way fast enough. It could come further north. The European does not do that, but it's a long way out. We just wanted to see if this is a storm. We're not talking about storm tracks or anything like that, so please don't ask. Nobody knows. Now, the GFS, what does the GFS do? Out to sea. See that? And again, with every big snowstorm that's ever been on the East Coast since I've been doing this for 25 years, the GFS stays 7, 8, 9, 10, is always out to sea. Always out to sea off the East Coast. Always. Always does it. So, and again, remember, day 9 and 10 last time with the big Midwest blizzard, it was the GFS that was going bonkers with the East Coast winter storm, and the European had it in the Midwest. Okay? So again, for East Coast storms, you stick with the European as a general rule. As a general rule. There are exceptions, but as a general rule. Okay. And if we look at the ensemble, let's take a look. See. Now the GFS ensemble, you see how it's off the coast, right? See that? Off the coast? But let's look at the ensemble. This is the GFS ensemble mean. This is off North Carolina. This is not out to sea. This is out to sea. This is not. So the GFS ensemble is significantly stronger and closer to the coast than the operational run. Again, you want to have the operational model, the regular model, match the ensemble. And in this case, again with the GFS, it does not. So that's a warning sign to ignore the operational GFS and stick with the ensemble. And if we look at the individual plots, look at the GFS members here. Okay? So what you can see, let me show you what I'm blow this up here a little bit so you can see it. See these red numbers? These are all low pressure areas where the model says the low pressure area might be on Saturday morning, January 14th. And they're all just off the coast. In the classic, perfect track for a big snowstorm in North Carolina, Virginia, Maryland, Pennsylvania, New Jersey, into New York City and New England. Okay? That's what that's showing. That doesn't mean it's going to happen, but that's what it's showing. All right? And this is the beginning of it here in the upper left. This is, you can see the main low in Tennessee, very weak, new low forming in Georgia. And then over here in the upper right, you can see the low developing on Friday night with heavy snow already in the Carolinas, North Carolina, Virginia, Maryland, Delaware. The big Arctic high to the north. The GFS ensemble is a really good hit for everybody. Here's the European. Same thing. Now the European slides it off the coast a little bit. See that? Now, one of the reasons why the European slides it off the coast is because the energy coming in from the Pacific is so strong. La Nina is constantly driving everything to the east. So we have to see. That's what the European is showing here. I don't know if this is right, but again, look at all the red numbers right along the Carolina coast and then off the coast. This is a classic North Carolina, Virginia, Maryland, Delaware, southern New Jersey, maybe southeast Pennsylvania hit. Not that much in New York and New England based upon this data. But that's what the data is showing. I'm not saying that's right, but that's what, you see how it's taking off the coast. Okay, so New England and New York would not get the biggest hit out of this. This would be a lower mid-Atlantic, Virginia, Maryland, Delaware, Pennsylvania, New Jersey snowstorm. And maybe even West Virginia to some degree. And again, if we look at the ensemble, look at this track. Right off the North Hatteras coast, perfect Virginia's, Maryland, Delaware snowstorm track. Southern New Jersey, maybe even Cape Cod. If this is correct. I have no idea if it's correct. I'm just saying this is what it's showing. All right? But again, why is it taking it off the coast? La Nina, constantly driving it off the coast. If you look at our temperatures, yeah, it's cold enough. This is on Friday night, January 13th. There's the rain snow line. Make sure you can bring it forward here. Okay, you see this boundary here between the purple and the white here? That's the zero line. Everything, all the precipitation north of this is all snow. So you can see it's right over Norfolk, Richmond snow, Charlottesville snow, Raleigh's on the line, Winston-Salem is snow, Greensboro, Asheville, Roanoke, DC, everybody's snow, Dover, New Jersey. And then if we go a little further, this is now a Saturday morning. You can see everybody is way cold enough for all snow. And then finally, January 17th and 18th. Now this one is just Bravo Sierra, in my opinion. The operational GFS did this from this morning. You can see this is not correct. And the problem with this scenario, now maybe the cold air might be in place of the mountains. I suppose that's possible. But the problem is, look at the upper air pattern. Here's the European. Totally different. Bring this forward. This is extremely warm pattern. This is what we just finished going through, folks. This is the jet stream pattern a couple days ago. Here's the Pacific jet driving it in there. The ridge breaks down. The big ridge on the west coast collapses, flattened by the La Nina. Big, huge, positive anomaly here. Howling Pacific jet, mild temperatures, everybody. This is all rain. This is nonsense. It's not going to happen. I don't like the January 17th, 18th event at all. Okay, a lot of information there. Hopefully you enjoyed it. I love doing it. Sorry, but so much information. I could have made this another 10 slides, believe me. There's a lot to talk about. But anyway, so in summary, January 11th to 12th out to sea, but if it moves up into southeastern Canada, it will help the January 13th and 14th storm become a bigger event. So we'll see what happens. I think the January 13th and 14th event is a serious threat. How far north it comes, I don't know. Way too early to know. January 17th and 18th, I think, is nothing. This is meteorologist DT for Weather Risk. I'll see you over the Twitter page, on the website, and over on the Facebook page.